Adding more people and mandatory overtime to a late project often fails to shorten the timeline. Instead, this pressure creates a fragile environment where the project's margin for error disappears completely. These statistics prove the cost of traditional schedule crashing. 68% of these efforts add expense without actually shortening the critical path. Furthermore, projects compressed purely through overtime experience a rework rate that is 2.4 times higher than standard projects. We can replace that high rework failure mode with the crush method. This framework provides a controlled, sustained gain in productivity by focusing on 5 specific levers: crashing only the critical path, reallocating resources, unbundling dependencies, sequencing fast tracks, and holding quality gates. To apply this yourself, pull up your currently delayed schedule, pinpoint the absolute non-negotiable deadline, and list your active team roster. Meeting a deadline requires treating time as a strict mathematical variable rather than a test of team endurance. The process begins with recalculating your true critical path before you change a single date. This is the C in crush. Crash the critical path only. Apply compression exclusively to sequential tasks that directly dictate your delivery date. Managers mistakenly compress non-critical tasks with float. The task finishes earlier, but the final deadline doesn't move because it wasn't a bottleneck. Directing extra budget or effort toward these floating tasks is purely performative. It satisfies stakeholders without actually accelerating the delivery. If a task is not on the critical path, crashing it burns capital and morale for zero schedule gain. With your path defined, identify the specific blocking tasks that are currently preventing the next phase from starting. Before hiring new staff, you must account for the ramp-up tax. Adding a new person mid-project forces a senior team member to halt their progress to assist with onboarding. This shift often pushes the final delivery date further out instead of pulling it in. On a short timeline, this onboarding cost frequently exceeds the benefit of the extra hands, making the project mathematically later. This is the R in crush. Reallocate resources fast. Move your best senior engineers away from non-critical tasks and put them on critical blockers. Reallocating known talent is more effective than hiring new people because the existing team already understands the codebase and project requirements. The U stands for unbundling dependencies. Interrogate every sequential link. If a dependency is based on habit, run those tasks in parallel. Budget cannot fix a project that is sequenced incorrectly. You must fix the logic of the workflow before you spend additional money. The S represents sequencing fast tracks. This means identifying phases that can overlap because the subsequent task can start using only partial information from the previous one. Fast tracking is only safe when the rework cost is low. If the early assumptions from the first phase change, you must be able to adjust the second phase without a major loss of time. Unlike a blind gamble, safe fast tracking requires you to set defined checkpoints within the overlap to verify that those early assumptions are still correct. Real schedule velocity comes from parallel processing safe assumptions, not from demanding faster output from a poorly sequenced plan. The final letter, H, is for holding your quality gates. These non-negotiable checkpoints must be locked into the timeline immediately. Your acceleration techniques must route around these gates. You cannot shorten the schedule by pushing through or skipping your quality controls. If the schedule is still over budget or behind, you must use strategic descoping. This means treating scope as a live lever rather than something that is fixed and non-negotiable. Present a descope option to your stakeholders while you have time to pivot. Cutting a non-critical feature early is often the most cost-effective way to protect the deadline. Waiting for quality gates to fail because you refuse to reduce scope results in a critical post-launch patch and a loss of stakeholder trust. Review your updated schedule. By recalculating the critical path, reallocating seniors, and unbundling dependencies, you have built a plan based on evidence. These figures represent the potential impact. Correct application of these steps can yield a 14% gain in schedule compression while reducing the team burnout index by 61%. The data shows that projects hitting their date through extreme team burnout often result in a delayed failure. The high defect rates and employee turnover that follow eventually negate the benefits of meeting the original deadline. Consider your own experience. Have you seen more projects fail due to mismanaged headcount, excessive overtime, or incorrect budget allocation? Let us know in the comments. Successful project recovery depends on technical logic and critical path accuracy. It requires replacing the hope for faster work with specific, measurable adjustments to the project sequence.